My name is Ayan. So today what we are going to do is uh, do a very simple but very useful transformation using Apache Spark. Uh, the transformation is called pivot, and that's probably a very common and well-known transformation. So what we have is a data set where we have user ID, age, country, and number of calls made by the user to that country. And at the output side, what we need is user ID, age, and name of four different countries, and the number of calls, how many calls they have made to each country. So what we have is a row structure, and from there, what we are going to go is a columnar structure. Uh, so that is called a transformation called pivot. Now, the very standard way of doing it using SQL is going through another data structure, which is kind of interim data structure, where we have these rows, input rows, and from this input rows, based on the name of the country, we create four different columns and put the number of calls in appropriate column. So if the value is US, then all the other countries will get 0, and the column called US will get the value called 3. And same way we'll go for all the rows. And once we are done, then what we are going to do is we are going to uh, do a group by on user ID and age and sum each columns, right? So if I select the user ID x01, we have got this rows where that user ID has made calls, three calls to US, one call to UK, and two calls to Canada. And finally, if I sum it up, this will be my output record. And the country XX, because X01 hasn't made any call to that country, it will be 0. So now the same thing we are going to do with Spark. So this is Spark shell, PySpark shell. So where we already have the Spark context created. I have already created the data set in a variable called data, which represents the input data set. The first thing what uh, we are going to do is create our first RDD. So D is the first RDD. Now what we need, two things what we need. One is we need to filter out any additional country which appearing in this input data. Because yes, there can be additional countries, but now we are just interested in these four countries. And the same for the same way, we want to have a list of these four countries and their positions in the output data set. To do that, we just create a variable called countries. Now this variable, what it gives the valid list of countries what we are interested in, and the order of their position, how they should appear in the final data set. Yep. Now this variable is in Spark driver where we are currently in. But when we run the job, when we run something in Spark, the actual tasks will be launched at the executor end. But these values are not present in executor, so it will fail. So the easiest way to transport or ship these values to executor is do a broadcast. Because the broadcast is good when uh, the value that we are going to broadcast is small, uh, and in this case, countries is a very small variable. So now the variable called BRC, which will have the list of these four elements, will be present in all the executors. Awesome. So now let's write a filter statement, filter function. What this function is doing is it's just taking so this is my input tuple. It has T0 is user ID, T1 is age, T2 is country, and T3 is number of calls. So it's just validating if T2, that is my country, is in the uh, broadcast variable, and this is how we can access a broadcast variable brc.value. If it is there, then we are getting that record back. If it is not, we're just suppressing that record. So let's use it. So we can do filter and we'll use the filter function. Awesome. So we have got this DF. So now what we have done is uh, we have filtered out this record. Now we need something called reshape, which will do take this input format and output the purple ones, right? So what we get is a tuple of this records, and what we give output is the tuple of this purple values. So yep, we get four values, four uh, columns in input, and we get six columns in output. Output 0 to 5. Just let's take a quick look on what the values are. So let us do dfm equal to df dot map shape, and let's see how uh, dfm looks like. Yeah, so exactly the way we want. So we have got uh, user id and age, and the first value of the tuple, and then the rest of the stuff. So we have got these two part in one group and these four things in one group in a single tuple. The reason we have done this, because we want to group on the next step, so that's why we have created this part as a separate uh, key for this tuple. So this tuple is internally it's a key value pair, where the first group is the key and the second group is the value. Okay, so that's how our DFM looks like. Now, for Python, it's a funny thing is how it adds tuple. Let's see how it adds tuple in Python. Say we have got one, two. Now, if I do T1 plus T2, what it does is it appends both the, it merges both tuples. But that's what we don't want. What we need is 11 and 20. So that's why we are going to write another function which in our notion of adding tuple. So this is our notion of uh, adding a tuple. Now let's see what it does. Let's do at tuple t1 comma t2. Yeah, it gives 11 and 22. That's exactly what we need. So now it's very simple stuff. What we are going to do is we are going to do a reduce by key and use this at tuple to sum it up. How it will look like: result equal to dfm dot reduce by key, and the aggregation function we are going to use is at tuple. And awesome. So let's see how result look like. Yeah. So that's exactly how we need the result. If you remember, this is how we need the result. X02 should have 7648. It has 7648. And X01 we have 2130, and we have 2130 here. So yep, that's about it. So what we have discussed is how to do a pivot in Spark, how to use a broadcast variable for filtering and other purposes, and thirdly, how we can modify the aggregate functions to be used in reduce by key in a slightly fun and tricky way. Cool. Thanks for watching, and let me know if it helps.